So I'm really glad that you are all here today this morning. What we're going to talk about is PacketFence. I've been working there for 2 years, and it's the first time we talk about PacketFence at such large event. We've mostly done stuff locally in Montreal, so I'm really glad to be able to talk to you about it, and I hope I'll share my excitement. So what we'll see today is what's network access control, really briefly. We'll talk about the secret sauce, so how we do stuff and how it works. We'll talk about why open source has been very helpful for us, the good and bad of the 2 years as a lead developer and some lessons learned and some ranting, and then the future of PacketFence, so a bullet list of stuff we want to look at in the future, and some community begging for help and stuff. So who am I? I'm Olivier Bilodeau, working as a system architect for Inverse since 2001, lead developer of PacketFence. I'm also teaching information security to undergraduate students in Montreal. I'm really into open source. I'm also a new father. I brought my baby here at DEF CON for the first, she's 7 months old, so it's been quite something, the airport and all that. I'm also enjoying CTFs a lot, so we're with the Amish security team doing CTF, and also the CISSP groupies, and we did the DEF CON qualification 2 years in a row with mitigated success. I'm developing Tom Droid, which is an Android application too, and so if you want to be interested in what I do and follow me, here are the social stuff links. This talk will implement you drink, me drink protocol. So if I say something stupid, you can interrupt me and force me to have a sip of a good beer. The beer I chosen was, I need to talk about it, was IPA, California IPA. It's really good. So I hope I'll make some mistakes. And there'll be some beers. I only have these left. But for the debriefing, so people that come to the debriefing after the talk and have good questions, you'll have a beer. All right, so network access control. This is like, you guys, this is the elevator pitch. Let's not focus on that. You guys are smart and you know what most of it means, so we'll go fast. Authentication. Basically, authentication is map username to IP addresses or MAC addresses. So the firewall doesn't discriminate between users and IP addresses, where NAC, it's the core focus is to be able to know this device is owned by this person, and it's really the binding of the two that is important for NAC. There's admission. Admission is allow, partially allow, or deny users, and there's control. So control here is to watch for unauthorized stuff, including outdated antivirus, patch level, someone scanning corporate servers, spreading malware, etc. So network access control has the goal to do all of that. There's the usual sales pitch stuff that you see, which involves a loop between detecting a device, isolating a device, notifying administrators about the states of these devices, and remediation, which is a key point that we'll talk about several times, which is how to help the user to remediate problems, including updating his systems and stuff. So basically, it's know who is using your network and making sure they behave. And we're not talking who an IP address. We're talking who a username. So it's really important, an authenticated username. So that's. With time, what NAC has become, well, remediation of users, as I just mentioned, guest management. So a lot of people want to handle guests, put them on the internet only, no access to the internal servers. So it started to do that. Asset and inventory management. So it's there, it saw the devices, and so it categorized them for you, and you see it. And also, it simplifies the access layer configuration. So the more technical people come to PacketFence because they are tired of doing per port configuration, manually switching VLANs to on ports. And so with a NAC, the VLAN management is all done in the server and more transparently, and it simplifies the access layer configuration. So the secret sauce. The technology, mostly Perl, some PHP. We're leveraging open source. The asterisk means that I'll be talking about it in the future. I did that a couple places, so this is the concept. And it's designed with high availability in mind, so everything we do, we always think about, we use active passive clusters, and so it's really a core focus because network access control, if it's down, no one accesses the network, which is really bad. So it's from the ground up thinking in clustering in mind. Key design decision that we've made with PacketFence, we're out of band, so this is the, by opposition to being inline, which means that it's really the infrastructure that takes a decision. We're not in the flow to the packet flow out to the network. So if the server fails, it most likely fail in a sane state. So it's really by opposition to inline where you see that there's a firewall doing the decisions and the packet goes through the NAC device. So we're out of band, so no packet is going through the server. We're doing edge enforcement, so this means that the decision for access are done the closest possible to the endpoint, the client computer. So there's no, it minimizes the attack surface by a lot. A client who has not been allowed in the network cannot scan servers and do anything. He's like, the switch decided that it couldn't get access, so really the edge kicked him out, if you want. We use no agent, so this is a lot of the proprietary NAC are using an agent-based system, and so we decided that it was error-prone and buggy, and in a world where there are several devices coming out all the time, we cannot cope with developing agents for all of these. So we decided let's not do that and focus on a web-based captive portal instead. And so that's what we do. Listen to everything is also a big thing that we wanted to do, is we see everything that's out there. So we sniff the ARP, we sniff the MAC address when there are security violations done by the switches. When we see IPs, DHCP, we gather all that information all the time. If a user hit the captive portal, we record the user agent. So we're really about identifying everything that's on your network. And a lot of people are amazed when they first plug PacketFence. Even if it's not doing enforcement, they will see a lot of devices that they weren't aware about. So out of band, how we do the out of band stuff is we rely on SNMP traps. This was the first technique that we developed in 2007, which was the first step that we forked out of the original PacketFence project, which was based only on DHCP. So the SNMP traps, we have several implementations. One is for link up, link down events. One is for magnetification event with our, to my knowledge, a Cisco-specific trap. And then there's port security, which was at first Cisco-specific, but then got picked up by a lot of vendors. The port security, the advantage of port security is that you get the MAC address in the SNMP trap that gets sent to PacketFence, which means we don't need to go and spoil a thread going to the port and waiting to see the MAC address show up on the port. So it's really more performant. You have a comment?
If typos count, you have notification, not notification.
Oh yeah, that's right. Let's do it. That's good. Okay, so then we got radius-based technique that emerged, which is 802.1x or MAC authentication. We will talk about these in a sec. So we first implemented wireless MAC authentication because the customer demand was for wireless, to manage the wireless and the wired side with the same software, same solution, which has been great for us. Then we implemented wireless 802.1x, which is what most people know as WPA Enterprise. And then we implemented lately the wired MAC authentication and 802.1x pieces. So let's go into a little bit more detail. The SNMP trap enforcement works by event on the hardware that generates traps. We react to the trap. And then we use SNMP client to connect to the switch and then perform port authorization, so MAC address authorization on the port, and change VLAN if it's what is required to do the proper enforcement. So it's an asynchronous process if you want. For most of the vendor, it works really well. For some of them, we need to rely on Telnet or SSH because their SNMP interface is not good, which we don't really like. Yeah. So one of the advantage of the authorization and the edge enforcement by SNMP traps is that because of the asynchronous nature of the authentication is if, let's say, the system would fail in the last state that was established. So the port security trap is sent to PacketFence. PacketFence saw the trap, saw the MAC address, decided that it should have been in the VLAN 100. It will go and put the user in the VLAN 100. Then there will be no security notification that will be done by the switch because we authorize the MAC address on the port. So as long as not another device which has another MAC address which will generate a security violation and then the cycle again, then as long as you don't have new security events, the system will stay in the good state no matter if the PacketFence server is up or not, running or not. So it's really a great advantage for this technique. Now, digging into the radius-based approach, let's have a few reminders about the protocols related to that. Radius is a key value-based protocol for AAA. AAA stands for authentication. Oh man, how come I forgot? Authorization, thank you. I guess I'll drink again. Authorization and then audit. So it's a very infrastructure type. Accounting or audit, all right. I won't argue. You guys are right. Smarter than me. Twice. Okay. So it's an infrastructure protocol. There's nothing like the switch speaks with the server, and there's nothing that the client needs to implement. Let's not get into 802.1x so far. So if you look only at this piece, it's really infrastructure based. Now, let's build on top of Radius and see 802.1x then. What is it? Is extensible authentication protocol over Radius. So EAP and all that nasty PEEP, MS-CHAP v2, and then encapsulation over encapsulation and stuff. So it's adding a lot of new components to the pure Radius that we just saw. So the actor in 802.1x are the supplicant, the authenticator, and the authentication server. I've never saw any authentication server besides Radius, but I'm pretty sure you can do it with Diameter. So it's options. The supplicant is actually the client, and you need something on the operating system to support 802.1x. So it's not as transparent as Mac authentication is. And the client-side software has been integrated in Windows, in Linux, in OS X for a couple of versions now, so it's pretty stable. But we'll see problems with that later. And authentication, most people know it, authenticator, sorry, most people know it as the NAS, so the Network Access Server. All right. The protocol even allows you to send stuff to the client. So this is how WPA Enterprise is set up, is that it as part as the authorization and authentication, it will send the keys in this encrypted tunnel. This is all, if you see the little diagram, this is all pre-DHCP, so pre-IP, and this is why it's called port access control, port-based network access control. Mac authentication is simply taking a step back for 802.1x. When the device doesn't support it, we do a simple Radius authentication authorization with the Mac as the username of the in the